Hello friends, today we will understand the chapter 19 Motions of the Earth. Our Earth has two kinds of motions, one on its axis which we call rotation and the other around the sun which we call revolution. Rotation. The Earth spins on its axis like a top. The Earth's axis is an imaginary line that passes through its center. Its two ends are the North Pole and the South Pole. The axis is inclined to the plane of the Earth's orbit at an angle of 66.5 degrees. As you can see in this diagram, this red line is the axis, this is the South Pole and that is the North Pole of the Earth. And this is the equator. This axis of the Earth is inclined on the plane of Earth's equator at an angle of 66.5 degrees. And if we talk about the vertical line from the Earth's orbital plane, its degree is 23.5 degrees. The Earth completes one rotation on its axis in 24 hours. It is because of the Earth's rotation that the sun seems to us to be rising and setting, which causes day and night. When the Earth moves on its axis, half of its surface faces the sun at a time while the other half faces away from the sun. As a result, in that part of the Earth that receives the sunlight, it is day, while in the other part it is night. This phenomenon of alternating day and night is the result of the Earth's movement on the axis. We call this movement rotation, which it completes in 24 hours or in one day. Suppose if the Earth stops rotating, then one half of its part would be permanently in light, while the other half would have perpetual darkness. Thus, it is because of the rotation of the Earth that days and nights are caused, and they follow each other in all parts of the Earth. The Earth moves from west to east. It is also because of this movement or rotation of the Earth that the sun, the moon and the stars appear to us as if they move round the Earth from east to west. Now we will see how are days and nights caused. You have already read that the Earth's axis is inclined to the plane of its orbit at 66.5 degrees. The Earth remains tilted to one side while it revolves around the sun. This tilt is called the inclination of the Earth's axis. You should also know that it is always inclined in the same direction. It does not change its position of direction. As a result, one hemisphere of the Earth leans towards the sun for 6 months. During this period, greater area of this hemisphere receives sunlight for a longer time. Thus, the days are longer in one hemisphere, while in the other hemisphere, the days are shorter and the nights are longer. Hence, when the days are longer in the northern hemisphere, nights are longer in the southern hemisphere, and for the next 6 months, when the nights are longer in the northern hemisphere, the days are longer in the southern hemisphere. So in the northern hemisphere, including India, June 21st is the longest day and December 22 is the shortest day. The days and nights are always of equal length at the equator because throughout the year the sun rays shine vertically on the equator. The lengths of the days and nights increase or decrease as we move away from the equator, either southwards or northwards, depending upon the position of the Earth. Due to the inclination of the Earth's axis in the northern hemisphere, from March 21 to September 23, the North Pole receives sunlight continuously for 6 months, while on the South Pole, the sun shines continuously for other 6 months. In this way, at the poles there are days and nights of 6 months duration each. So this is the Earth's axis and this dark blue line is the Earth's equator. and you can see the sun rays are falling on equator directly, and the south pole is near to the sun while north pole is away from the sun. Days and nights are equal throughout the world on March 21 and September 23 because on these 2 days neither of the poles is inclined towards the sun. These days are called equinoxes. Revolution. The motion of the earth around the sun is called revolution. While revolving around the sun, the earth follows a fixed route or path which is known as its orbit. The earth completes one circle in approximately 365 days and 6 hours. That is 365 and 1/4 days. But for the sake of convenience, we calculate a year in complete days, that is 365 days. In this way, we add 1 day, 6 into 24, 24 hours in the 4th year. So, we count the revolution of earth in days only, that is 365 days. But in every fourth year we add 1 day extra. This year is called a leap year because 6 into 4. If we count 6 hours 4 times, then it gives the result 24 hours, and 24 hours make 1 day. So we add this 1 day in the 4th year, and this year is called a leap year. Thus, every 4th year in the solar calendar has 366 days. This extra day is added to the month of February because it has least number of days. In an ordinary year, February has 28 days, while in a leap year it has 29 days. The phenomenon of or change of seasons is caused chiefly by the revolution of Earth around the Sun and the inclination of the Earth's axis at an angle of 66.5 degrees to the plane of its orbit, which constantly points to the same direction. It can be understood with the help of a diagram which shows 4 positions of the Earth during its revolution around the Sun. So in this diagram you can see the Earth is tilted in one direction only, and this causes the seasons, the revolution of Earth around the Sun. As you can see, the North Pole is inclined towards the Sun, so the northern hemisphere will receive more sunlight, so the days would be longer and the nights would be shorter. And in the northern hemisphere it would be summer. And if we see here, the northern hemisphere is away from the sun, so it would be winters as the days are shorter and nights are longer. The position on June 21. The North Pole is inclined towards the Sun and the South Pole is away from it. The rays of the Sun fall vertically on the Tropic of Cancer, 23.5 degrees north. Major parts of the Northern Hemisphere are lit by the sun rays. As a result of that, the days are long and hot, and it is summer in the Northern Hemisphere. This position on June 21st, when the sun shines vertically on the Tropic of Cancer, is called the summer solstice. So we can see in the diagram that the rays are directly falling on the Tropic of Cancer. So it is summer solstice in Northern Hemisphere. Position on December 22nd. The South Pole is inclined towards the Sun and the North Pole is away from it. The rays of the Sun fall vertically on the Tropic of Capricorn, 23.5 degrees south. So as you can see in this diagram, the North Pole is away from the Sun. Therefore, the days are shorter and nights are longer. So it's winter solstice in Northern Hemisphere, that is 22nd December, and it is the shortest day in the year. And here in the summer solstice, June 21st is the longest day of the year. As a result, days are long and hot there. It is summer in the southern hemisphere. Thus on December 25 every year, when Christmas is being celebrated, it is winter in the northern hemisphere, as in England, the USA, India, etc. But it is summer in the southern hemisphere, as in Australia. Remember, when the sun shines vertically on the Tropic of Capricorn, it is called the winter solstice. The position on March 21st and September 23. Both the North Pole and the South Pole are neither inclined towards the sun nor are away from it. The rays of the sun fall vertically on the equator. As a result, days and nights are of equal duration throughout the world on these 2 days, that is March 21 and September 23. So, here in the diagram, you can see that it is spring equinox and this is autumn equinox. And there are equal days and nights in both of these cases. The seasons in both the northern hemisphere and the southern hemisphere are similar. It is neither very hot nor very cold. These 2 days when there are equal days and nights throughout the world are called equinoxes. On March 21st, it is the spring in the northern hemisphere. It is called the spring equinox. On September 23, it is autumn in the northern hemisphere. It is called the autumn equinox. So in the southern hemisphere, the seasons are opposite to the seasons in the northern hemisphere. On the equator, the sun always shines vertically overhead. Therefore, there is only one reason on the equator. It is a hot, long and hot summer.